Thank you for watching our demo. I'm gonna start by demonstrating the connections of the ultrasonic sensor as well as the car motors. First, we will start by the H bridge. We've connected each side of the wheel with the output pins, and as for the enables, for each side we connected it to PWM pins. This is the enable A, responsible for controlling the right side of the car and making it move. We've connected it to PWM pin 9, and for enable B, which connects the left side of the car, we connected it to PWM pin 10, and the N1, 2, 3, 4 are responsible for directing the car, but we didn't really need them in our code. And out 1, out 2, out 3, and out 4 signals the car. And as for the outs, those are the ones that are responsible for the car to move. When we disconnect them, the wheels do not rotate anymore. Second, I'm gonna talk about the ultrasonic sensor. It has two main signals, the echo signal and the trig signal, and this is our input that detects motion. It signals the trig pin, and according to the output of the trig pin, it signals the LED and the buzzer to turn on. Now I'm going to talk about the code. First of all, it took this function. Now I'm going to talk about the code. We've added this feature into task 1, and it takes a relatively higher priority and a larger memory stack size. We added the digital write to N1, 2, 3, 4, which are responsible for the motion of the car when the enables are turned on high. And this is the trig pin. We only use it to signal the LEDs. Okay, and here's our duration. When the echo pin signals high, we calculate a certain distance, and we check on this distance. If the distance is smaller than 10 centimeters, it signals the enable to turn on 0, to analog write 0 or 100, and here the LED pin, which is a digital pin, to go on high. And finally, we've added the task delay until, and we've signaled it to 500 milliseconds, which is a relatively lower number, so that it prioritizes it and synchronizes it relative to other tasks.
Now we're going to talk about changing the gears. We changed the gears using the joystick. To switch between the gears, we divided the X and Y range into 4 parts. For the N, P, D, and R, we used the LCD display to display them up besides the temperature. It has 5 connections. The ground is connected to the Arduino. It sends 2 analog signals, and it's connected to the VCC also from the Arduino. The night detection mode sensor is used along with the LED light when it's dark, and when it's brighter, the light turns off. It sends an analog signal through pin A4, and it's also connected to the LED. The night detection mode has task 3 with lower priority. Has task 3 with lower priority than task 2, which has the joystick part. Task 2, to display the gears, we take the analog signals X and Y, and we draw the joystick. The function F draw joystick info is responsible for dividing the joystick into 4 parts, so we can display the four gears. In task 3, for the night detection, we take the analog signal from LDR status, and then this if condition controls the brightness of the night detection sensor. So it displays the LED pin into high when it's dark, and it displays it to low when it's brighter.
Talk about the temperature, clock, and date. First, talking about date and time, we have an RTC module connected to the OLED screen showing date and time, showing current date and time. The RTC module has 4 pins: VCC, SDA, SCL, and ground. Each one is connected to the corresponding pin in the OLED display. Talking about the temperature, we have a temperature sensor with 3 legs, one connected to the VCC, one connected to the ground, and the other is connected to the Arduino. This sensor is used to detect the current temperature, which is displayed on the OLED. And now going to the code, here we initialize the date and time with the adjust method called from the RTC library. Here we have a display method, which we get the date and the time by the RTC.now, and get the temperature using the analog signal and connected to the A0 pin in the Arduino. And here we are converting it from Fahrenheit to degrees Celsius and displaying the temperature. And here we are initializing date and time through if conditions, and here we're displaying the date and time. Here we create the task 2, giving it high memory because it contains so many tasks, and giving it a certain priority. This is the task 2 method, where we call the display method and give it a delay time 1 second.
We are going to talk about the last feature in our car, which is the MP3 module. It have 5 pins. 2 of them is connected to the external speakers. The other 3, one is connected to the ground and the other is connected to the VCC and the last pin is the RX, which is connected to a resistor to avoid the occurrence of any noise in the playing of the songs. Then we have 3 buttons. Each one control the playing of the song. One is play pause, one is play next, and one is play previous. Here we are playing the next song, then we are getting back to the previous song. And now let's consider the code. We created the task 4 to control it. It has 4 functions, which are play, pause, play next, and play previous to control the playing of the songs. Also, we are controlling the buttons using semaphores and flags. So all of that we put it in task 4 that we created up in the code, and we initialized it in the setup function. For the buttons, both the 3 buttons are connected, are having a common ground and connected to the Arduino through 3 digital pins, which are which are 34, 35, and 37, and here is the flag which controls also the buttons.
Thank you for watching!